care about maxes and mins because they actually mean something in the real world. So let's look at a couple of applications of maxes and mins. So here I'm telling you that the height, measured in feet, of an object that's thrown into the air is given as a function of time. Now time's going to be in seconds, measured from the instant that we throw the object into the air. So time 0, we throw the object into the air. And it's given by this formula, h of t, so it looks like we're using h because that stands for height, and t is our time. And it's negative 16t squared plus 48t plus 64. Where did that come from? This whiteboard. Okay, now there is some physics behind that. I'm not expecting you to be able to come up with this formula. So sometimes students see word problems and they say, oh, it's a word problem. Ugh, let's panic. Well, most often the hardest part of a word problem is coming up with the equation. There it is. We just have to read it off the whiteboard. Okay. Now, in a physics class, you might have to come up with that based on the law of physics and some initial conditions. In this class, we're given it and we just have to use it. So I kind of like to just draw in my axes to remind myself of what's going on. I'm putting time here, and that's in seconds, and I'm putting height on the vertical axis, and that's in feet. So instead of calling things x and y, I have t's and h's, but that's going to remind me what's what. Okay. I can see this is going to be a parabola, and it's going to be a parabola that opens down. Okay. So I've only drawn the positive time axis and the positive height axis because I really only care about things from the time I throw the object up into the air until the time that it lands. Once it lands, it's not going to burrow beneath the ground, so this would be the portion of the parabola that I'm concerned about for this problem. I started up here because I could see just real quickly if I plugged in 0 for t, we weren't starting at a height of 0. We were starting up here at 64. Okay. So we're concerned with finding this. Notice we were asked about a maximum. Pretty cool, we've got a max because it's a parabola that opens down. I'm just going to remind myself that instead of x and y, I've got time, which was on the horizontal axis, and height, which was on the vertical axis. Now the questions I'm asked are, what's the maximum height of the object? That's looking for this. That's usually my y value. And then what's the time when we're at that height? That's looking for that. That's usually what I think of as the x value. Now I'm going to answer these questions in the opposite order in which they were asked, because when I'm finding the vertex, it's usually easiest to find the input value first. So don't assume just because the questions were asked in a particular order that you need to answer them in that order. I actually need to answer B in order to have the information to answer A. So at what time? Well, here my A was negative 16, my B was 48, and my C was 64. The input value of the vertex is just the opposite of B over 2A. So that's going to be a negative 48 over 2 times negative 16. Those negatives will cancel, and I can reduce things a good bit, because 16 actually goes into 48 3 times. So this is just going to be 3 halves. Okay. So that's 3 halves seconds. So basically 1.5 seconds after we've thrown this into the air, it's going to be at its maximum height. Okay. That's the answer to part A. Notice I did make sure to include the units. That wasn't 3 halves of an hour, that was 3 halves of a second. Okay. And what is the maximum height? Well, to find that, I'm going to have to just plug in. I'm going to erase my beautiful picture here because I need some space. So we're just plugging in the height at 3 halves. We're plugging in 3 halves to calculate that. So that's going to be negative 16 over 1 times 3 halves squared plus 48 over 1 times 3 halves plus 64. So that's negative 16 over 1 times 9/4 plus, I'm going to go ahead and reduce here. 2 goes into 48 24 times, and then 24 times 3 is going to be 72 plus 64. And here I can also reduce. 4 goes into 16 4 times. So we've got negative 4 times 9 is negative 36 plus 72 plus 64. That's going to give me 36 plus 64 is going to give me 100. So the maximum height would be 100. Make sure you include the units. That would be 100 feet off the ground is the maximum height of that object.